Sorry. Yes?
No, thank you very much.
Okay, that's the end of it. Now let's go to the second session. So the next presentation will be given by Ronald Wertlen. He is project leader in DFN S2S. He will explain, of course, what is S2S, because this is subject of the presentation. He studied computer science, philosophy, and psychology in South Africa. He worked in the US for a while, and Germany. His main experience is in the field of internet search and decentralized business application. Ronald, please. The mic.
Of course.
Perhaps it's better to take this one, I think.
Yes. I was
working.
wondering why. Thank you. Now I don't have to shout. Can everyone hear me? No? And now? Perhaps a little higher? Even higher. No, I don't attach it to my... Shall I start again then? Good afternoon, ladies and gentlemen of the floor, and ladies and gentlemen in the internet. My aim today is to explain to you the project DFN S2S in a fairly comprehensive manner, starting with the context, going into what you can do with S2S, and then also looking at results that we expect to get and possibilities within the project. But first, I'd like to tell you a little bit about the company I represent. I work for Neofonie gmbH. We are a small software house in Berlin. We have created a few public services. The most popular German internet search service, Fireball.de, as well as a popular newspaper search, Paperball. We produce content management products and internet search products. We have funded this project to 50%, and DFN does the rest. We have experience with large companies like AOL, Bertelsmann, T-Nova. So we produce high-performance software. Then I'd like to briefly tell you about a new product of ours. And this really sounds like advertising, but it's related to DFN S2S in that it is about ad hoc search. What you can do with Neofonie Search is it's not a new idea. There are other providers of such services, although most of them have left the market. You come to our website, and if you can speak German, you just follow these 4 steps, which are presented on the left, and you can, in a matter of clicks, build a search engine for your own website, and embedding a little bit of HTML on your page, you have search for your site. And one of the nice things about this is that if your site is small, you can have it for free, which is also, I suppose, a good reason to mention that. Definitions. Well, Anna has done a very good job of defining peer-to-peer. So I would just like to give my own spin to that. The DFN is the NREN in Germany. What a peer is concurs exactly with what Anna said, but specifically I'm talking about somebody who has installed the S2S software, and a peer-to-peer network. Well, I think that's actually the part that Anna explained very well. Right, and in search, I'll be using the term search quite often as an abbreviation for research in full text research in documents, as well as search in metadata and fields. Right. Good, so what are the goals of DFN S2S? The goal is to improve search by implementing the task of indexing the deep web and other hidden content using a peer-to-peer approach. So basically what we are doing is at the endpoints, at the peers, we want to install complete search engines which are able to index documents which are not only local to the computer but local to the intranet of that peer. This is these intranets are fundamental parts of the deep web. They're not accessible from the outside, and this poses all kinds of security questions, of course. Our focus is on search. The peer-to-peer technology is handled by Juxta, which was also introduced by Anna. And our focus is on creating a working network in Germany for researchers. So we really want to deploy our software and get it working so that researchers can publish their documents and search on the internet. How will they do this? They will simply install a software package, and the aim is that the installation process is 1 or 2 clicks and you're ready to roll. So S2S is a network of peers which support search in local document sets. And from a user perspective, it is a piece of software that you can also use to index your own documents. So this contrasts to what we've seen before in the SETI at home and these kind of distributed computing enterprises. The user can have a vested interest in using the software in that they can search their own data, which perhaps they couldn't do before, and search it in a very simple manner with just a few clicks. It is also an online search service, so we have an online component which allows a person with a simple web browser to access the data in the network as well. In the next slides, I will be comparing S2S with conventional search engines like Google or Fireball. So this diagram represents the functioning of the Fireball search engine, which is really the same as FAST or Google. There's a central location. Let's see if the mouse works. There's a central server here, and it sends, well, it crawls through the hyperlinks of the web just by following hyperlinks and taking perhaps random starting points in the internet, in the web. What this means is that there are a large number of sources, these are the deep web, scattered all around, which are inaccessible to search engines. What we are seeing currently is that search engines are not keeping track with the massive explosion of data we're seeing in the internet. The opening speaker yesterday was quoting the figures, 550 billion documents in the deep web and a growth rate of 7 million pages a day. These centralized search engines are just not keeping pace with the growth. What we're seeing more and more, if we use Google, is we click on links and the information has vanished. So the information isn't current anymore. And of course, it's centralized. If there's a break in the internet between us and the central server, then we cannot access the information anymore. Of course, there are also advantages to these models. We can be sure that we have a complete picture of the information in the index. There aren't parts of the index that are missing. And the availability is controlled, at least at the local level, by the provider. What we would like to do with this picture is to place our nodes, our peers, within computers that are now outside the web and which tap the resources in this deep web. For that, we need, obviously, the cooperation of the scientists. The advantages here will be that this really does scale better, and the information is more current. Our aim is not to index the entire deep web, of course. We would like to focus only on scientific information and information that is of interest to researchers. Disadvantages of the scheme, well, there are several. They belong to the classes of disadvantages of peer-to-peer, things like security and availability. You don't know if you have a complete picture of the index and things like that. In the next two slides, there are textual representations of the differences. Perhaps. Anna also had a table of this manner. On her slides, one saw the scalability. Excuse me, data set. Anyhow, on Anna Preston's slides, the scalability was in reverse. She represented peer-to-peer networks as not scaling. And that's very interesting. The reason for that, of course, is that one presumes pure peer-to-peer networks, well, I'm guessing the reason for that is that pure peer-to-peer networks use a flooding algorithm, sort of like Nutella. And it has been shown lately that this just does not scale because eventually, as we have seen at the University of Rome as well, the bandwidth is used up and nobody can do anything anymore. And, of course, the network administrators are forced to shut the peer-to-peer systems down. Right. So why should one use science to science? The principal answer, of course, is to search. It presents an alternative searching model. As we will see just now, you can easily build communities and link into these communities in a content-based manner. We will hopefully have more content to present than current search engines. And of course, the up-to-date nature of the information is guaranteed by the model. There are only current entries, or at least 2 hours old entries that can be found. There is a download aspect of Science to Science. Having found some resource, what you will see at the beginning is only an abstract or a short excerpt. And one can download the entire resource if it is available for download. So why would a researcher share data using S2S? Well, they can create communities ad hoc to share the data. One of the things we identified was publication space is limited in today's journals. It's difficult to publish data as well. Not everyone has a local web server on which they can place their documents, because often the access to these web servers is restricted by administrators. So for ad hoc publication, They may actually be interested in indexing their own material, so they may have quite selfish reasons for using the software, and they may wish to make their own search engines. So here's a recap. We have publication, building communities, search, and download. These functions are all supported by the peer software, and here's an overview of how they work. Providing data is, we heard Anna Preston mention that as well. This is a typical term from Juxta. So to provide data, one has to simply install, and then one is prompted to join a community. One can also leave it on the default, so one doesn't actually have to do anything. And then publishing documents is a one-step process. And once one has published some documents, you can also check the contents of your index to see if something slipped by, because you can specify a URL or an FTP address, which is a directory in the system, and then the software takes care of iterating through all the subdirectories. So it may happen that you have included a document by mistake that you did not want to include. Right. The process is simple and safe. That is to say, the Juxta software provides a safe platform for the peer-to-peer connections. This diagram shows now the provider in the center of the picture and the remote resources on the right. The user has specified a URL. What happens now? The provider goes and gathers the data from these remote sources. It converts formats like PDFs, HTML, Word documents, and LaTeX into XML. We saw earlier that Morpheus is based on XML. XML is a great structured format, and it then indexes this data. So in this process, we will hopefully have identified things like authors and dates and titles out of documents and made them available via Dublin Core metadata fields. It is easy enough to adapt the system so that if you have a particular XML format to allow search in your own metadata. So how do we build communities? The communities, in order to explain that, I should first state that this is a basis on a query space construct, which is defined in the Juxta search standard. Query spaces direct searches to particular providers belonging to a particular community. So as we see in this graphic, one can ad hoc create spaces, and providers can place themselves within a single space, or they can place themselves within multiple spaces. And this can be a content-based grouping or a geographical-based. It is completely ad hoc. In the center, we see the hubs. Hubs are primarily, in this case, used for some semantic routing. That is, a consumer wishes to query a particular query space, and the hub knows to which providers it should route the query. So this is in stark contrast to pure peer-to-peer approaches such as Gnutella, in which the entire network is flooded for a query. Juxta Search defines the following architecture. We have peers on the edges of the network, which are either providers or consumers. The providers provide the data, the consumers send questions. Through a process of registration, the providers tell the hubs what their interesting data is. This process of registration is, of course, can be manual, but we don't, a la peer-to-peer, expect that the users will trouble themselves with this. So the process is also entirely automatic and is driven by the indexes that are created when the user specifies a single URL. SJS hubs, by their central nature, are also able to optimize relevance ranking. If you have a huge amount of data, relevance ranking is essential to bring good data to good information to the researcher's attention. This is the core of Google's success is, in fact, relevance ranking. At the hubs, we could also implement things, and we are looking at implementing spam inclusion. For instance, by automatically creating registrations from responses. Right, this is a background slide, which I'll be skipping, which explains how hubs may be connected. Right, so how does search and download work? Well, the user has three methods of accessing the network. He can either use the integrated graphical user interface, he can use a web browser, or he can use a mobile device. The resulting user interface looks like a normal search. What happens when a user searches? Well, this is a process specified by Juxta Search. The consumers, the end user poses a query. The software sends the query to a hub, and the hub now has a series of steps through which it goes in order to find out which providers fit the query. This is, in fact, called semantic routing because it matches the meaning of the query with the meaning of the provider. Having found a provider, a response comes back. We also cache responses for a few hours. The reason for this is that users have become spoiled and they expect really fast answers. As Anna Preston also mentioned, the peer-to-peer networks have a latency that they incur. The reason for this is that the query must always be propagated through the network somehow, and it can be the case that there's a slow provider which has extremely valuable data, and it responds, but it's too late because the hub has a certain timeout. It has already sent a response back, and so this valuable message is lost. If, in this case, we cache the replies, and the user, just by resubmitting his query, can then see new data, which will also have been specially marked as new, and will appear at the top, so that one can get quick feedback as well as quality feedback. Download is pretty simple. The reason why download goes through the hub in the first place, although the consumer already knows potentially where the document is to be found, is that we take this information as a measure of confidence in the provider. When somebody is interested in the provider's information, that is a measure of confidence. So what information can you find in SJS? You find information about documents that are located at the providers. You can also find information about the provider peers measures of time in the network, numbers of queries answered, and also these measures of confidence. There's also information about the peer network itself, the activity in the network, and something that is not in the web browser interface in order to encourage users to install the software. From the Swing GUI, you can also query information about the query spaces in the network. So, perhaps of interest to network administrators, there are several points of possible points of control of the network at the hub and provider and consumer. And we are, this is not a focus of the project, but we are implementing measures at all of these points in order to improve the quality of the network and the quality of the data in the network. Then I'd like to say something to the underlying technology. Juxta provides the basic peer-to-peer communication functionality. An important point about Juxta is that it tunnels through firewalls automatically by using polling. That means a provider in DFN S2S has no open ports, does not appear to be a server to a network administrator. So in other words, to block an S2S provider, one would have to use more than packet inspection. One would have to also analyze traffic. Neofonie Search is the search engine software. This is placed on top of Juxta, and it provides the functionality which we saw in the slide on data provision. It gathers information, it filters and enriches the information, and it also indexes it. We also have a system to swap term indexes between the providers, so the providers will have a global measure of information in the peer-to-peer network, which is also an important step to improving relevance ranking and in improving registrations. So some words to Juxta. It is an open source community project started by Sun Microsystems. The aim is to qualify as an Internet Engineering Task Force standard protocol. There is also an implementation of this protocol in several languages, Java, C++, and .NET. The idea of the software platform is that it demonstrates that the protocols do work and that they do scale. And it is a freely available infrastructure on which to build peer-to-peer networks such as SGS. It is a maturing technology, and the 2.0 version recently was brought out. Neofonie Search is innovative. We power large applications like the AOL website with millions of page impressions per day. There are two basic components, a gathering component and an indexing component. The gathering component is in Java. The indexing component is in pure C++, available for several platforms. And it is, in fact, an XML indexer with full-text capability. This means that you can pose queries using constructs like XPath in order to precisely specify fields. And, in fact, the nature of your XML is completely immaterial. You can index any form of XML with it. Right, so much to the technology. What do we expect? Well, first of all, a question. the system usage of a peer-to-peer system. As we heard earlier, peer-to-peer is a social paradigm, and it really depends on the usage. That it depends on people using the system, and how the main difference between peer-to-peer and grid, as far as I'm concerned, is that in peer-to-peer, users are motivated through selfish reasons. They want to achieve a goal, and in doing so, the software enables the work that they are doing for themselves to transmit, to produce a cornucopia of the commons. That is, the work turns the work that they do for themselves is shared and sort of explodes into a massive abundance. We heard this. I don't know if anyone was in the lecture on organizing NRENs. It's kind of like sharing knowledge. In sharing knowledge, in giving you knowledge, I retain the knowledge, but in taking up the knowledge, you enrich what you have received, and well, the knowledge just grows. So it really, the question here is, will S2S achieve the critical mass required? Because if nobody is using the system, there will be no knowledge or no information in the system, and nobody will be prompted to use it. We expect that there will be a great exposure for scientific information. It's a fairly simple expectation. We do not expect that there will be a great amount of community building in the first stage. That really depends on the question of whether the project will achieve critical mass, because in order to create a community, the researcher or a group of researchers have to think, and that, of course, is extra work. So it will be interesting to see that. We are also expecting that researchers will not, continuing on, will not significantly invest resources and to, say, produce registrations or to make use of the full capabilities of the software. Rather, they will just install it, have a look, and if it works, then they will continue to use it in an automated sense. We're expecting that the operation will be smooth and secure. We are also expecting problems with legal issues because of copyright. In this sense, we can only provide spam control through explicit voting of consumers. We cannot really control that. The whole idea is that the network runs without administrative intervention. Inappropriate material may also be included in the network. We are hoping to block that with simple heuristics at the hub. And we are also expecting commercial demand. We have contacts with a large company already, and we are looking at building knowledge management networks on the basis of S2S. Here's a brief roadmap to put you in the picture. At the moment, we have just published a new website on which one can apply to become a beta tester of the program. And the website address is right here. And thank you very much.
Thank you. Question from the floor? Waiting for question. Just I'm asking one question. You gave explanation on the goals, different goals of the project. and what you expect from this project. As a user, if you would try to convince me of using this software, what would be the best or the strongest reason to use it? And finally, I would ask you, how likely is it that your scientist community will use this software?
Right. So to the first question, I would, well, if you approach me directly, I would have a look and see what your needs are, because the whole point of S2S is to fill your needs, and I would hope that if you come to me with this question, that you in fact have a problem publishing your data, and that journals and magazines just cannot cope with the amount of data that you have to publish. So let's say you run a series of experiments which just produce massive amounts of data which you do want to publish. I would say to you, yes, we can do this. Your second question was, the answer to that is how likely, the question was how likely is it that researchers will use this software? Well, that depends on how successful we are in promoting and marketing the software.
Before getting another question from the floor, what will be the, you hear me? Yeah. What will be the status from this software? Will it be open source?
Unfortunately, because we use our own products, neofonie search, these are proprietary. Of course, because we use a standard protocol to exchange the messages, it is very simple to take open source software, which has similar functionalities. XML indexes in Java already exist, and to recreate this functionality. The problem with that software is, of course, we expect it is not as efficient.
Okay, so in your project you have designed an architecture, you have produced, I would say, software, but in fact in following this same architecture and in choosing other pieces of software with open source, I can do the same.
Yes.
That's what you are saying.
Yes,
okay.
Yes, quite.
Question? Is there any question? No question? I think it's time for coffee then, if there is no coffee. Okay, coffee break. Thank you, Ron, again.
Thank you, Jean-Paul.
And thank you to you.
And thank you, the floor. Yes.